42. It doesn't matter to me. You choose.
42.
Okay, 42. So I'm going to copy it and then stop sharing. The radius of a circular disk is given. So the radius is 24 centimeters with a maximum error in measurement of 0.2 centimeters. And you will tell me what this is. Use differentials to estimate the maximum error in the calculated area of the disk, part A. Max area. And this is very important. Using differentials and to estimate. So it's an estimate. We're not interested in the exact. And then part B, what is the relative error? And then the percentage error. Okay, perfect. So we have a disk. Here's the disk. And it has a radius. And the radius has an error of 0.2 centimeters. So the radius is 24 centimeters. And the error is 0.2 centimeters. I would like us to identify what this is.
It's dx.
Correct. I don't mind changing this into x if you prefer x. And then this is dx. If you want to keep r, then this will be dr. It doesn't matter. The notation is not important. Just remember we have to be consistent. If this is x, then this is dx. If this is r, then this is dr. Perfect. Excellent. So in part A, how do I determine the area of a circular disk?
2 pi r squared.
Okay, so let's write it here. The circumference is 2 pi r. The area is pi r squared. Perfect. So pi r squared. Good. So they're asking us now to determine the estimate of the error, the estimate of the maximum error in the area. So if this is the error in the radius, what will be the estimate of the error in area denoted by? Oops. What would that be? What will be the notation for the estimated error in the area? What do you think?
F prime minus dx.
Right? So the delta A is the exact error. The dA will estimate the exact. That's why we have dA approximately, delta A approximately dA. So if we're talking about an error in the radius, this is the error in the approximate or the estimated error in the area. So can anyone give us dA for the given function? Ready.
F times 24 times 0.
Okay, here's a note for everybody. No numbers yet. Please don't give me any numbers yet.
Is it pi 2r?
2 pi r
times dx.
Very good. This is the formula for dA. Excellent. Now I can determine it. 2 pi r is 24. dr, what was it? I put it away already, 0.2. So this is, what is 0.2? 0.2 times all this is 0.4. What is it? 0.2 is 2 over 10, or 1/5. So 48 divided by 5, right? What is it? Or 24 times 0.4, right? So 9.6 pi. Measurement unit. Measurement.
Centimeters.
Careful.
Squared.
Very good. Perfect. So that was our first part. Find the maximum area, the estimate of the maximum area using differentials. We did. Excellent. This is it. Yes, you can approximately further. I put my calculator away. I don't know why. So what is it? 9.6 times pi, approximately 30.16. So see what happens here? An error of 0.2 in the radius, centimeters, creates an error of 30.16 centimeters squared in the area. Yes, an approximate, but it's quite close because this is small. Okay, now part B. Find the relative error and then percent error. Okay. When we talk about relative, we're really talking about error relative to original. So what is the error? You gave it to me. What is the original? The original is this, the error is this. So I will simplify as much as I can. 1 pi with 1 pi, 1 r with 1 r. So then I have twice dr over r. Okay, so twice. dr was 0.2, r was 24. So this is 0.4 over 24, or 4 over 240, and I divide 1 over 60. Measurement unit. No measurement unit. None. Why? Because this is in centimeters and this is in centimeters. Simplify. Now, percent error, same thing, but I have to take 1 over 60 and divide 1 by 60, and I get 0.0167, which is 1.67%. Of course, that's the final answer for the percent error. So what does it mean? It means that the relative error to the original, right, is 1.67 of the original. Any questions? I would like to also look at another example with linearization and linear approximation. As you know, this is a calculator. It requires a lot of work, and we looked at an example, and thank you so much for asking that. But I would like to look at the simpler example with linearization here. And the differential we already did. So just an example, please choose. And let's find a linearization of a function at A. Which one?
2.
2. Let's look at 2. Very good. Any questions? Any questions, please? Okay, so yes, of course. Yes. So we have f of x equals e to 3x, and a is 0. Is this okay?
Yes, thank you.
Thank you. Good. So I know that the linearization by definition is f of a plus f prime of a times x minus a. A is 0. So then I have f of 0 plus f prime of 0.
You're still sharing your screen.
Of course I am. So sorry. Sorry about that. So the linearization is f of a plus f prime of a times x minus a, and we know where this is coming from the equation of the tangent at that point. So now a is 0, I plugged in 0, 0, and x minus 0 will be just x. What I need to find is f prime. Can anyone give us f prime? Ready?
3
Very good.
times 8.
Very good.
Yeah.
Thank you. So what would be f prime of 0?
1
Times,
0.
careful, 1
3
e
times
to,
1.
yes,
3.
very good. So then f of 0 is 1, so 1 plus 3x, done. That's it. That's all we need to determine. And this is the end of chapter 3. In chapter 4, we have 8 sections. And in chapter 5, we have 5 sections. And we are down to 11 meetings. 3 tests, 3 reviews, and 1 review for the final. So then I have to finish 2 chapters in 2 meetings. No, it's not going to happen. But that's the time left. Okay, any questions, anything? I posted a previous test if you want any questions, if you want to go over anything. So any type of problem that you would like to look at? If not, I will pick. I know we only have like 7 minutes, 6, 7 minutes left. So if you want to pick, please do. If not, I will. I know what I'm looking for. I want to look at a problem with the cost and marginal cost. There must be a problem. There must be one. No? Ah, voila. Okay, perfect, 96. The cost in dollars of producing X units of a certain commodity is, so this is 96 from the review. So C of X equals 0.000407 x cubed minus 0.02 x squared plus 2x plus 920. Okay, find the marginal cost function. That is C prime of X. That's the marginal cost. Then it's asking us to find C prime of 100 and explain. And then compare C prime of 100 with versus cost of producing the 101st item. Perfect. Okay. So we're given a cost function, and we are asked to find what it's called the marginal cost. The marginal cost is simply the derivative of this function. So in part A, c prime of x, that's a piece of cake. I have, just to make sure that I have enough zeros, 1, 2, 3, 21 x squared minus 0.04 x and plus 2. Done. So this is the marginal cost. Then in part B, they're asking us to plug in 100. Okay, let's see if we can do this by hand. 0.00021, 10000. This times 100 is minus 4 and plus 2. So these are 4 zeros, 2, 4. So 2.1 minus 2 equals 0.1. So I plugged in, and now I'm asked to explain. Okay. Okay. So c prime of 100 equals 0.1 predicts the cost of producing the 101st item. How do I know that? Because this is basically DC. DC is c prime of x times dx, right? So c prime of, better remind you the entire formula. So f of x plus dx, we've been using this since last time, because f of x plus f prime of x dx. So please don't forget dx here. So when x is 1, right? So when we're looking at this is 100 and this is 1, this will be 100, this will be 100, and this will be 1. That's the tiny error. So if I produce 100, but then I think of producing 101, this will be the cost for the 101st item. The difference will be this minus this. The exact difference will be f of 101 minus f of 100. So the exact cost will be c of 101 minus c of 100. This is the exact cost. The exact. But what will be the approximate? The approximate will be this. So approximate is dy or dc, which is c prime of 100 times 1. Because it's times 1, this is it. This predicts the cost of 101st item from here. So that's the meaning. That's part B. So now they're asking us to compare this to the exact. No worries, no worries. This is the exact. So delta C will be C of 101 minus C of 100. And this should be very close to that. So I'm going to enter this function in the graphing calculator, if I find it. Y, clear, clear. And I will put in 0.12347 x to the third, and then minus 0.02 x squared, and then plus 2x, and then plus 920. And then simply plug in 100, and then plug in 101. And the difference should be exactly or very close to that 0.1, as expected. So C of 100 is 990.1 minus 990, exactly 0.1. So if you want to take a look at that, you can. That's what it is. Okay, 10107 to be exact. 10107. 10107. That's the exact. So the exact is this, and the approximate is that. Any questions?